Hi, my name is Jenner Barnuevo, and my math writing project is on derivatives and how they relate to the algebraic concept of slope. For the first question, we are given a graph of a curved function, and we are told to estimate the derivative of f of 1.1. Because we are told to estimate, we do not need to find the exact slope or the instantaneous rate of change at point 1.1. We find the average slope of its two closest points, which will give us a close estimate. As we know, the slope formula is y2 minus y1 over x2 minus x1, which is given on this paper. This formula can be used to find the average rate of change within the two closest points, in which case we find that the two closest points to 1.1 is 1 and 1 and 1.2 and 1.5. When we plug in the y's into the slope formula, we are given the rate of change for y values as 0.5, and the same goes for the x values, in which we find the average rate of change for the x values as 0.2. When we divide these two, 0.5 and 0.2, we get the slope as 2.5 for the secant line. So therefore, because the secant line is the average rate of change, we get the derivative of f of 1.1 as approximately 2.5. The second problem requires the use of the formal definition of the derivative, or the limit definition, also known as the limit definition, which is the limit as h approaches 0 of f of x is equal to f of x plus h minus f of x divided by h. The formula is essentially the same formula as the average rate of change, but in this formula, h is the rate of change between the 2 points on a curve. We find that f of x plus h is h squared plus 2hx plus x squared plus 2. We find that f of x is the same as the original function, x squared plus 2. We plug in those two into the formula, and we find that x squared is subtracted out and 2 is subtracted out as well. We also find that h is reduced, and we plug in the 0 into the h of this function, and thus we find the derivative of the function using the limit definition as 2x.